Okay, can you review what's on the screen real quick?
Okay, I see a web page with a title BioniChaos Biomedical. There's an audio overview at the top, and below that there are several tools listed, including a modality comparison bubble chart, a cochlear simulator, and an advanced EEG signal simulator. It seems to be a platform for biomedical tools.
Yeah, that's right. Can you keep reviewing? I'll just scroll down the page a bit.
Okay, scrolling down, I see more tools listed. There's an epilepsy and cardiac health and interactive evidence review, a synthetic noise generator dashboard, an interactive explorer for public multimodal biomedical datasets, an ECG simulator, and a brain-computer interface simulator.
Okay, can you keep reviewing? Can you do take a critical stance? Don't mind dark humor as well.
From a critical standpoint, the website offers a variety of tools for biomedical data, which could be valuable for researchers and students. However, without further testing, it's difficult to assess the quality and usability of each tool. Also, the sheer number of tools might be overwhelming for some users, and the descriptions are quite technical, which might limit accessibility to those with a specific technical background. Additionally, the purpose and target audience for each tool could be made more clear.
Okay, yeah, I love you being critical. So out of the tools that we covered so far, which one would you like to test?
Based on the descriptions, the Interactive Explorer public multimodal biomedical datasets seems like a promising tool to test. It allows for exploring various types of biomedical data, which could be quite insightful. It also mentions focusing on common data types like EEG and ECG, making it potentially useful for a broad range of users.
Okay, so this is the tool. What do you think?
This Signal Explorer tool looks promising. It provides an overview of different biomedical signal types and allows you to explore their characteristics and potential uses. It seems designed for educational purposes and to help users understand the strengths and weaknesses.
Okay, can you just get rid of the fluff and just be highly critical about it? Can you overview what is it you can see on the screen and what the buttons are doing?
The screen displays the Signal Explorer tool, presenting 4 buttons: EEG, ECG, PPG, and FNIRS. Below these buttons, there's information specific to the selective signal type, currently showing EEG details. The critical vulnerability is the tool's reliance on static information and predefined data. It lacks the ability for users to input their own data, perform interactive analysis, or explore complex scenarios beyond the provided examples. This limits its practical use for in-depth research or real-world applications, making it primarily a superficial educational tool. The buttons only serve to switch between preloaded signal descriptions, lacking any true interactive functionality for data exploration.
Okay, we actually have other tools for that, but I just scrolled down the page. Can you keep reviewing this particular tool and let me know what you think about it, how it can be improved, be highly critical?
Okay, focusing on the Dataset Deep Dive section, it provides a list of multimodal datasets with filter buttons for different signal combinations. While it's helpful to have access to these datasets, the critical flaw is the lack of direct integration with interactive analysis tools. Within this section, users might only view dataset descriptions rather than actively explore and visualize the data directly. To improve, integrating interactive analysis features within the Dataset Explorer, like the ability to plot signals or apply basic analysis tools, would significantly enhance its usability and practical value for data exploration.
Okay, just getting rid of the fluff will just sum this up. Can you just scroll down the page a bit further? Yeah, it doesn't fit the screen really well. But yeah, can you review what you can see on the screen real quick? Be critical.
The current section titled The Core Challenges identifies 2 key hurdles in using multimodal data, ensuring high signal quality and managing incomplete data. It presents these challenges conceptually with a bar chart and a grid showing missing modalities. However, the critical drawback is the lack of practical solutions or interactive features within the section. It merely points out the problems without providing any interactive ways to explore or mitigate these challenges. To be more valuable, this section should include interactive simulations or tools that allow users to experiment with different signal quality or data imputation methods, providing a practical understanding of how to address these challenges, rather than just describing them.
Okay, so back to the main, back to the landing page. Hey, can you again give a quick review of the tools out there, and which one would you like to test?
The landing page provides a variety of tools, including a modality comparison bubble chart, a cochlear simulator, an advanced EEG signal simulator, and various interactive explorers for biomedical datasets. Based on the previous discussion about the need for more interactive analysis, I would recommend testing the Interactive Explorer public multimodal biomedical datasets to see if it provides better interactive features for exploring and analyzing the data. This would allow for a more practical evaluation of how interactive features can.
Hey, we just did this right now. Can you just cut the fluff? Get the Can you talk like a 30-year-old data scientist and yeah, suggest any other tool that we can review?
All right, let's cut to the chase. Since the Interactive Explorer for multimodal datasets didn't quite hit the mark for interactive analysis, let's take a look at the Advanced EEG Signal Simulator. It seems more focused on interactive exploration of EEG signals, allowing users to customize brainwaves and simulate artifacts. That could provide a more hands-on experience for understanding the data, which was a key limitation of the previous section. Let's check that one out.
Okay, this is what it looks like in a review real quick. Be critical.
All right, looking at the Advanced EEG Signal Simulator, it's definitely more interactive than the previous tool. You can play around with different brainwave presets and simulate artifacts, which gives a much better understanding of how these signals behave. However, it's still a bit limited in terms of advanced analysis features. It's great for visualization and basic understanding, but real data scientists would need tools for more in-depth analysis, like advanced filtering, frequency analysis, and statistical measurements. Integrating those features would make this tool much more powerful and practical for serious research. So, looking at the details, you've got brain state presets to simulate different brain states, and artifact simulation to add muscle or eye blink artifacts. The page has several interactive components. The brain state presets dropdown lets you select different brainwave states. Below that, the artifact simulation sliders allow you to introduce muscle artifacts and eye blinks to see how they affect the signal. Further down, the fine-tune wave sliders let you adjust the amplitude of different brainwave frequencies, like delta, theta, alpha, and beta. On the right, the power spectrum and simulated EEG waveform display the effects of your adjustments in the frequency and time domains, showing you the frequency changes and the resulting EEG waveform. It's a good way to interact with EEG signals. The different brain state presets represent various cognitive states. For example, relaxed/meditative emphasizes alpha waves, which are associated with a calm but alert state. Light sleep/drowsy, theta, highlights theta waves, typical of early sleep or deep relaxation. Deep sleep/dominant delta focuses on delta waves, which are prominent during deep sleep. And focused concentration/beta emphasizes beta waves, associated with active thinking and concentration. Each preset gives you a baseline to see the typical brainwave patterns in those states.
Okay, and what now I'm changing the artifact, the muscle artifact and the eye blink artifact. Well, you can't see the whole screen. We also have the time series domain. I don't know why it's not visible in one go kind of thing. It's to my display. But yeah, can you see it right now and review? Let me know what's happening in a critical way.
Yes, I can see the time domain waveform now. As you adjust the muscle EMG artifact slider, you can see the waveform becoming more jagged and regular, especially at higher levels. This represents the interference from muscle activity. When you increase the eye blink EOG artifact, you'll see larger, slower deflections in the waveform, mimicking the electrical signals caused by eye movements. The graphs show how these artifacts distort the underlying brainwave signals.
Right, and we meant to have like a play demo mode that just goes automatically through the different settings, adjusting each slider probably one at a time. Well, what do you think of that?
I think that's a great idea. A demo mode would make it much easier for users to quickly understand how each parameter affects the brainwave simulations. It would provide a guided experience, making the tool more accessible and intuitive to use.
And what else, if you had to review how this tool compares to other tools out there, either open source or commercial, like how would you go about it?
To compare this tool to others, I'd first identify its key features, like the brain state presets, artifact simulation, and the ability to fine-tune brainwave frequencies. Then, I'd look for other OEG simulators, both open source and commercial, and compare their functionalities. Key comparison points would include the range of features, ease of use, visualization quality, and the flexibility of the simulations. I'd also consider user feedback and reviews to assess the overall performance and usability of each tool.
And what other artifacts would you add?
Considering the artifacts panel, you could add simulations for other common EEG artifacts, such as electrode noise, which can appear as high-frequency interference, or movement artifacts, which cause larger, slower disruptions in the signal. Adding these artifacts would provide a more realistic and comprehensive simulation of EEG data, helping users understand the challenges of real-world EEG recordings.
Okay, and in terms of the preset states we have is deep sleep, light sleep, relaxed meditation, and focus concentration. What other preset brain states would you add?
You could add presets for different cognitive states, like active learning, problem solving, or even creativity, which might show different combinations of brainwave frequencies. Also, including presets for specific neurological conditions or varying levels of alertness, like high alertness or fatigue, could be very insightful for users. These presets would offer a broader range of scenarios to explore.
And how about the overview about at the bottom of the page? Can you? I'll just scroll through it. The? Can you summarize it real quick?
The overview at the bottom summarizes the simulator's purpose as an educational tool for exploring EEG signals and brainwave characteristics. It explains how it combines different brainwaves and artifacts to create synthetic EEG data, useful for learning, algorithm development, and understanding complex data. It also describes the different control panels and visualizations available. Finally, it mentions potential future enhancements, such as adding more waveforms, artifacts, advanced analysis, and real-time data import.
Okay, and how would you improve the description?
To improve the description, you could add more details about the specific parameters that can be adjusted and their impact on the simulated EEG signals. For example, explaining how adjusting the amplitude of different brainwaves correlates with different mental states would be helpful. Additionally, providing more information on the technical details of the simulation, such as the algorithms used, could enhance the understanding for advanced users.
And do you have any, like looking at the simulator, do you have any critical questions about it?
One critical question would be about the accuracy and realism of the simulated brainwave patterns, especially for complex mental states. It's important to know how closely the synthetic signals represent real EEG data in various conditions. Another question could be about the limitations of the simulator, such as the range of artifacts it can simulate and the complexity of brain states it can model, compared to actual brain activity.
And just scrolling through the previous tool, the previous page, how does it compare to what we saw on the previous page?
This page provides a comparison of different biomedical modalities, including EEG, ECG, PPG, and FNIRS. Unlike the previous tool, which focused specifically on simulating EEG signals, this section gives a broader overview, describing the measured processes, temporal and spatial resolution, and common artifacts for each modality. It's more of a comparative and informational resource rather than a simulation tool.
Okay, and how does it compare to what you currently see on the screen? That's the landing page, is pre-selected neurological web applications that we have. Can you give a quick overview, looking through it, give a quick overview? Don't mind you being critical.
This landing page presents a collection of neurological interactive tools and resources. Unlike the specific EEG simulator we discussed earlier, this page offers a variety of applications, including simulators for cochlear implants, interactive dashboards for medical data, and tools for visualizing and analyzing various brain signals. It provides a broader range of neurological tools, each with its own specific focus. A critical point might be to assess the depth and complexity of each tool, as they vary from simple simulators to more advanced data exploration tools.